Hello friends, welcome to this session of R programming. And in this session, we are going to learn how to use R as a graphing calculator to learn behavior of equations. R is a programming language very powerful in computing. It can be used to simulate equations, run those for thousands of values and see the results in the form of graph. For example, this is an equation for saturation kinetics, Michaelis-Menten equation for enzyme kinetics. As substrate concentration goes on increasing, reaction rate increases at fixed enzyme concentration. The maximum velocity which can be achieved at excess substrate concentration is called as Vmax, and the substrate concentration at which reaction velocity V is half that of Vmax is called as Km. Note here, Km is substrate concentration. Effects of changes in Vmax and Km can be understood very effectively if we learn them using graphs. Run the equation for various values of Vmax and Km, plot the graph and see the effect. Let's go to R. We are in R studio. Let's have S. S we are going to here get 1 to 100. Run that to C, and that S is there and 1 to 100 values are there. Now we'll have Km is equal to, this time we'll have Km is equal to 1.5. Vmax is equal to 50 we will have, and then we'll run that equation. V is equal to Vmax into S substrate concentration divided by in bracket Km plus substrate concentration bracket complete. We'll run that. That Vmax not found. We have not run these two values. We'll run that so that those will go into memory, and this will also go into memory, and we'll run the equation. And now we have the Vmax as 50, Km as 1.5, and these are the values of V. Now these values will plot to see the actual process, that S plot is the function and S is the substrate concentration, V is the velocity, and S is X and V is Y. We'll run that and we are seeing that, but we'll make that type line. Type is equal to L, and we'll run that. A line is there. Now, just to see effect of increasing Km, we'll have Km2 is equal to 25 we'll write, excessively high, and then we'll copy the equation, this one, and we'll copy the plot also, require both, and in equation we'll change this Km to Km2 and V2 V2 V2. We'll run that, and it is saying at Km2 because we forgot to run this Km2. We'll run that, and we'll run the V2 also, and we'll run that plot. We need to change, and that will make lines so that it will get added to the existing plot, and we'll run that. Lines is not getting added, S will remove and run that. Okay, this V we forgot to change to V2, and now we'll run that. Why it's not getting added? Lines. Yeah, that line has got added, and we can see that because of increased uh, Km, the reaction velocity is coming down. We'll change the color to make it in contrast to above line. We'll make that color as blue, and we'll run that again, and you can see that increased Km decreases the V value, reaction velocity. Now we'll have the third one. We'll copy this entire thing, all these three, and control V. We will change according to our requirement, that Km3 will make to 50, and this V2 is equal to V3 we will make, and Km2 is equal to, we will change Km3, and in lines this will be V3, and color will make that as red, and we will run from this Km3. got stored into memory, got stored, and got stored. And still, the reaction velocity decreased down. As Km increases, reaction rate goes down. Now we will reduce the Km and see its effect. For that, we'll have Km4, Control C, and run that. That Km4, and we'll have that at 0.5. Earlier, for this black line, it was 1.5. We have reduced that, and this V4, I will call it, and this Km4 will be there, and this V4. All lines we need to run. Km4 V4 got calculated, and this line, and we can see that this line is above the line for Km 1.5. Therefore, as Km decreases, reaction rate increases, and we have understood that reaction rate is inversely proportional to Km. And here in equation we can see that Km is in denominator, and that's why that increasing Km decreases the V4. This is for Km. Now we will go for Vmax. That Vmax 2 will use there, and that Vmax 2, earlier Vmax was 50. We will see what Vmax was there. Vmax was 50. Now we will make that Vmax as 20. We'll reduce that, and we'll copy this equation, these two, and this time we'll use the green line, Control C and Control V. This we will call as V5, and this KM4 will make keep it as the same, but Vmax will change to Vmax 2, and we'll run this, and this V5 and color will make as dark green, and run that. Control enter. Object V5 not found. We have not run that. That Vmax 2 was also not there. Vmax 2, Vmax 5, and the line. And we can see here the line at very bottom, because reaction rate decreased. Reaction rate decreased. The reaction rate should have been that Km4 was there, and here that reaction rate should be there. But as Vmax 2 decreases, this is the reaction rate. Okay, and now we'll try to increase the Vmax and to see the effect. That Vmax is equal to Control C and Control V, Vmax 3, and earlier we have the Vmax is equal to 50, and here we will increase that to 75, and I think that will not go in this one, but still we'll try that. This will not be in this plot, I guess. Then Vmax 3, here that in line that y value will be V6, and we'll run that to see the effect. And that V6 not found, we forgot to run it again. That Vmax 3, we'll run this, and we'll run this, and that's not there in the plot because that has gone beyond this plot range. And instead of that 75, we'll make that as 55 to see the effect. Run that, and run that. Yeah, that's there somewhere, but still, as we increase the reaction rate, reaction velocity has increased. Now we can see that Vmax is in numerator, and that's why increasing Vmax results in increasing reaction rates, and decreasing Vmax results in decreasing reaction rates. Vmax is directly proportional to velocity. Yeah, and that's all. And here we have learned that we can use R as a very powerful, very strong graphing calculator to learn how equations behave at different parameter values. If you have liked this video, please hit the like button, subscribe to my channel, and share this video with your friends. And if you want notifications of my new videos, please click the bell icon. Thank you.